You may have a question that talks about two roots of a quadratic where there's a relationship between them. So, for example, it might say that one root is 5 more than the other root. We can represent that by simply saying that we've got one root, let's call it alpha, and then the other one is going to be 5 more than that. Now, very quickly, you could have an alternative. You could say, well, that one root is alpha and the other one is 5 less than that. They in a sense, would actually end up giving you two answers, or whatever question you have, that would be, you get the correct answer. But generally speaking, it's always better to go with positive relationships as opposed to negative ones. So my personal choice would be go with the first one I went with there. If a question mentioned two roots where one was a multiple of the other, so for example it might say that one root is 5 times the other, then that's a multiplication relationship where you might have one root and you have the other which is 5 times that, so alpha and 5 alpha. Again, you could choose to go with alpha and say that one is a fifth of the other, and again that would give you effectively the same relationship, but again it creates more difficulties. It gives you a fraction. We don't like those, so again my choice would be in this instance to go with alpha and 5 alpha. So how might this manifest itself in a question? Well, they might say to you, okay, we've got a quadratic, x squared plus x plus a constant, I'll just use the letter k, and this quadratic, we don't know what value of k is, but they do tell us that the roots have a difference of 5. Okay, so basically one root is 5 more than the other, or you could see it as being 5 less than the other. So first of all, we'll just set ourselves up with the two roots. We'll just say alpha and alpha plus 5. They have a difference of 5. And if you remember from this formula that we are looking at, if we think about the connection between the sum and the products along with the quadratic, our sum is going to be alpha plus 5, which gives me a tied up expression of 2 alpha plus 5. But that sum, whatever the sum of my two roots, has to be equal to the negative coefficient of x. So basically, minus the sum would be the coefficient of this quadratic. Now the coefficient is plus 1. So plus 1 is equal to minus the sum. So therefore we could say the sum is equal to minus 1. Wouldn't take very long to be able to solve that and find out what alpha is, and then find out what my second root is, which would be 5 more than that, which would give me 2. All I'm doing is I'm relating my my sum expression taken from finding the relationship between the two roots, and that sum expression can be compared to my quadratic expression. So minus the sum, so if we can think of this in here, it's actually minus 1 lots of x, and that's where I get my minus 1, as you see there, is where I get where I say my sum is equal to. And my product is the multiplication of those two numbers, but my two numbers are, we found out, is minus 3 and 2. So if I multiply them together, I get minus 6. So we can see here now that minus 6, which is my product value, is the number we add on the end of the constant, so my k must be equal to minus 6. And my full quadratic is x squared plus 1x minus 6 equals 0.